Welcome back to chi-square goodness of fit test. Now, in the previous video, with the same data, we're able to identify whether this observed gathered data is different from the expected result, because the chi-square goodness of fit test is a specific type of test for categorical data where we are trying to determine whether there's difference or significant difference between the observed data and the expected results. In our first video, we are trying to determine whether a certain claim of DepEd saying that there are no preference, or grade 11 entrants show no preference on their senior high school strand selection. So that's of equal distribution. Okay, so if that's the expected, we are going to test whether this gathered data for 200 grade 11 entrants with their responses is significantly different as to that. That's the coverage of the first video, and if you would like to visit that, its link is posted below. But the idea or the result or the interpretation of the result on that specific video is that grade 11 students show no preference. Okay, they show no preference with regards to their senior high school strand selection. Now, for this second version, we are going to examine if there's a certain degree or percentage of proportion that DepEd is now claiming. Okay, so that would mean that the expected result is not of equal distribution, but a distribution similar to their claim. What if DepEd's claim is that 30%, okay, of grade 11 entrants chooses STEM, 32% chooses ABM, 26% chooses UMS, and 12% chooses TVL. As you can see, 30%, 32%, 26%, and 12%, they are no equal distribution. So we are going to determine whether this set of data here, the observed data, okay, would help us create difference or significant difference with our claim, our first null hypothesis later of no difference. And it would it lead to this claim that our distribution is most significantly different from equal distribution? Let's try that. Of course, before we start, let's not forget the 4 assumptions for our goodness of fit test, and we have verified this already on the same set of data before, but I'm just going to repeat it here. So the assumption number 1, we only have one categorical variable. Our variable here is the senior high school strand selection, and it's called categorical because we have 4 categories: STEM, ABM, UMS, and TVL. Okay, so that's check. Assumption number 2, independence of observation. That would mean that the response of student number 1 is not necessarily affected with the response of student number 2. Their responses are independent and based on their own preference. Check. Assumption number 3, that the observations or the responses are mutually exclusive. That would mean that each student only has one response. If student has more than one response, it's either we remove the second or we remove the student entirely so that we could have a correct interpretation later. So 2 only chooses UMS, etc., etc. And for our assumption number 4, at least 5 expected frequencies in each group. In short, there would be at least 5 responses that would include STEM, 5 for UMS, TVL, and ABM. But of course, we have 200 responses here. We would expect that it's at least 5 or more than 5, which also has already verified in the previous video because we have the table for expected frequencies. But of course, we're going to do it here as well. Now, aside from the assumptions, for us to be guided, let's consider this hypothesis. The null hypothesis is, even if the claim is of distribution, the null hypothesis is hypothesis of no difference. So we could reject that and accept the alternative with distribution if we are to reject that later. So our null hypothesis is that grade 11 entrants still show no preference with their senior high school strand selection. If this is not true, we will reject that and we will have our alternative hypothesis: grade 11 entrants show no preference with their senior high show preference in this case with their senior high school strand selection. Now we can only reject or fail to reject our null hypothesis depending on this region of rejection. Our region of rejection, or we reject HO if our p-value is less than 0.05. And if we do that, there is preference now among grade 11 entrants, senior high school student selection, which could be similar, or which is now closer to the claim of DepEd of 30%, 32%, 26%, and 12% distribution. Okay? So with all that in mind, let's now start the analysis. Same as earlier, click Analyze, go to Non-Parametric Tests, Legacy Dialogues, and once you hover to that, you will have your chi-square here. This is now the pattern for chi-square goodness of fit test. We also have a different pattern for chi-square test of independence. We will discuss it in a separate video, but this is for the goodness of fit test. Again, Analyze, Non-Parametric Tests, Legacy Dialogues, chi-square. Once you click that, you will have this dialog. You can see here your two columns. And by the way, before we go back here, before we go to that, let's go back here. Our variable view, or if you're going to go to our variable view, again, we already defined our terms here. Would like you to go here to nominal, because again, even if we assign the value 1 for STEM, 2 for ABM, 3 for UMS, 4 for TVL in this manner, you can simply have 1 and STEM here. You can add, click add, but it says already there. Okay, so let's remove that. Even if you assign STEM as 1, ABM 2, UMS 3, 4 TVL, it's still nominal because those numbers doesn't have any order. Okay, so of course we just simply label it preferred senior high school strand selection. So I just would like you to go to that again, because to highlight the idea of categorical or nominal data. Okay, let's go back to data view, and again, let's have that process. Analyze, Non-Parametric Tests, Legacy Dialogues, chi-square. Click that, you will have this. So that column for preferred senior high school strand, simply place it here for your test variable list. Okay, now here's the difference between this video and the previous one, because in the previous one, again, we simply let all categories equal here, because we are talking about the expected value of equal distribution. This time, when we have the expected distribution claimed by DepEd, 30, 32, 26, and 12. So we're going to click these values here. Ayan. Once you click that, this will be opened now, and your OK is not available, because you're going to manually input here your expected result from your expected distribution. Let's start with STEM, because that's the one earlier. STEM, 30% chooses STEM. 30% of 200 is equal to 60. You might want to use your calculators for that. So click here, place 60, simply click add, just like that, and you will have your 60 here. Take note, this is still not okay, because you have 4 categories for your categorical variable. So simply continue, and take note that it should be on the same order. The next order is for ABM, and 62%, was it 62? Yeah, 62% chooses 32 rather. 32% chooses ABM. So 32% of 200 is 64. So 64 and add. Okay? We still need to add more, because we have more than, we have exactly 4, even if it's already okay here. So the third one is for your UMS. UMS is 26%. 26% of 200 is 52. Add. And finally, 12% chooses TVL. 12% of 200 is 24. You would try to see here that this is actually just equal to 200. 60, 64, 52, and 24. Okay, this is equal to 200. Once you're done with that, you can now click OK. But of course, let's visit options and see descriptives, just for the addition of our discussion. Okay. So this is the difference between the two. Of course, if you would like to go back to all categories equal, simply click that, or again, go back here, because you already have your values. So this is our preferred, this is our expected distribution as claimed by DepEd. Let's click OK. Once you click OK, you will have this result. This is your first table, descriptive statistics. So you'll have your 200 cases now. This mean here, so 2.3, don't worry about that, because your 1, 2, 3 are just nominal in data, but we're just trying, this statistics is just trying to take the mean, but of course just for the record alone. Let's proceed here. As you can see, this is the observed n. This is actually the number of counts here, meaning, by the way, your STEM is 1, right? You could even click this here. You can click this button. You would see that your STEM is 1. Okay? Your 2 is your ABM. Your 3 is UMS, and your 4 is TVL. By the way, when we count STEM here manually, it should return to the same value of 65. So 50 chooses ABM, 45 chooses UMS, 40 chooses TVL. These are the observed values. But take note, in the previous video on the case where equal distribution, even if this is different from 50, because 200 equal distribution divided by 450, our result before was of no preference still. The difference is not significant. But this time here, you will have this 65 and then so on and so forth. Now you can see here that these expected values are your values that you have placed in your expected values earlier. The 30% of 200, the 32% of 200, the 26% of 200, and the 12% of 200. And you will see here the residuals. These are just simply the difference of your 65 and 60 observed minus expected, because in manual calculation for our chi-square, we are to subtract observed and expected, square it, divide by expected, and sum or add all. I didn't want to talk about that because we have SPSS in this manner. Now I would like you to go to our last table. This chi-square value here is the chi-square value as mentioned when we do manual calculation, and that's what we're going to compare on a chi-square distribution table using this degrees of freedom for categories -1, that's 3. Okay, but let's talk about this value, 0.002. This is less than 0.05. If this is less than 0.05, that would mean we are to reject our null hypothesis, stating that there are no preferences for our senior high school strand selection of our grade 11 entrance, telling us that there is really a preference, and that the claim of depth now of this distribution 30, 32, 26, and 12% is closely similar to what is true. Okay, because this is the value here. We have rejected now our null hypothesis. Take note that in a previous video, as mentioned, again, the link is posted below, we have shown that there's no preference because the value is greater than 0.05. In this case, it's less than 0.05. Don't worry about this. This is on the idea that it counts the percentage of expected value is less than 5. That's the fourth assumption for chi-square test. But since we have here 60, 64, 52, and 24, that they're all greater than 5, then that is met. That's why we have here 0.0% of failing our assumptions. So going back here, this set of data shows that against our expected results, there are significant preference. Okay, now there are preferences because of our expected results. It's different from the equal distribution because our null hypothesis is of no difference. Based on this and comparing on the expected results based on the proportion claimed by DepEd, we have really established that there is really preference among the selection of our grade 11 entrants on their senior high school strand. Okay, so this is the second video for our goodness of fit test. See you in the next video.